This episode is brought to you by WeatherGuard Lightning Tech. At WeatherGuard, we make lightning protection easy. If your wind turbines are due for maintenance or repairs, install our Strike Tape Retrofit LPS upgrade at the same time. A Strike Tape installation is the quick, easy solution that provides a dramatic, long-lasting boost to the factory lightning protection system. Forward-thinking wind site owners install Strike Tape today to increase uptime tomorrow. Learn more in the show notes of today's podcast.
Welcome back. I'm Alan Hall.
I'm Dan Blewett, and this is the Uptime Podcast, where we talk about wind energy, engineering, lightning protection, and ways to keep your wind turbines running. All right, welcome back to the Uptime Podcast. I'm your co-host, Dan Blewett. On today's show, first we'll talk a little bit about port infrastructure over in Europe. It looks like about $7.9 billion is the estimate of some upgrades that might be needed just to handle some of the increased volume of shipping from offshore wind. We'll talk about spiral welded tower technology, which could be a major player as far as construction on site without having to ship these really long towers. We'll talk about the Mocean Blue X wave energy prototype, which is now off the Orkney Islands in testing phase. And the U.S. is actually investing in that to see if we can get some of this wave power up and running on the West Coast. And lastly, we will talk about Australia breaking an output record with 5,899 megawatts and some of the plans for this very big energy hub in the southwest side of Australia to potentially create green hydrogen and other fuels for use in heavy industries, power stations, shipping, and more. So, Alan, let's start with infrastructure. Obviously, this was going to be a problem. We've talked about this, just the need for bigger ships, for installation vehicles, for bigger ports. As these things grow and there's more demand for it, this is going to stress everything. So, I assume you just see this as a natural progression for all these countries just to make this work, right?
Oh, sure. Can you well imagine that if you have an existing port that closed in the 60s or 70s, which is probably, at least in the United States, was what a lot of ports are going to be, all the infrastructure you have to put in to make them viable to handle offshore wind. It can be roads, right? Heavy duty roads to carry heavy things for trucking, all the power requirements because you'll be putting factories near the ports. So all the power demand you're going to put there, all the other bits and bobs of buildings, it's just going to be massive amounts of infrastructure, sewer, water lines, the whole thing. I always guess that when they come up with numbers for infrastructure projects, it's roughly 50% of what is actually needed to finish the job. So they probably need twice that amount to do it. It's always so intensive on labor and on materials. And with inflation right now, you wouldn't want to start it today, but you need to start it pretty soon because you know that this influx is coming. It's like building a small city right on the port. And one of the more difficult places to build a city is on a port for a variety of reasons, right? I mean, the land may not be suitable for heavy structures. You may have to build it up. You've got to deal with trying to get roads in and out. And there's a lot of cities near the seashore, so it's not easy to do that. And the cost of infrastructure has just exploded in the last 10, 20 years. Do you see this as being a massive problem that if I'm GE or if I'm Siemens Gamesa, I don't want to pay for all that stuff. I don't want to put all the sewer lines in for this whole up and down the port community that needs to be built up. I don't want to pay for that. You want the community to do it.
Well, and we talked about how it seems like the margins might be relatively thin for some of the manufacturers like GE and Siemens Gamesa, where they might not have all that extra cash. I don't know the deep financials of it. I'm not sure anyone really does unless you work for those companies. But you talk about raw materials increasing in price right now, whether it's fiberglass or concrete or especially steel. And then you ask them to pay for it. And I'm not sure that's what's being talked about here, but someone's got to pay for it, obviously.
Right.
And you wonder if it is the OEMs, the manufacturers. So,
well, it's like a sports team in the United States. The sports teams don't want to buy the stadium in which they're going to produce all the revenue from. This is not much different, but it's on a much larger scale. And as you know, in Washington, D.C., all the development that happened around the Nationals baseball park, there's a lot of cash put in that, I don't know, square mile. It's going to be larger than a square mile in all of these ports if they're going to get serious about offshore wind. So it's a massive amount of money. And how many times you're going to replicate that along the eastern seaboard of the United States? Same thing's going to happen in Europe. How many times you're going to replicate this thing to make it close to where the actual wind turbine site is? Because you don't want to haul anything if you can avoid it. So that's why I think they're off by a factor of 2. We'll see as it goes, but I don't see GE pouring a lot of money on infrastructure, and I don't see Siemens Gamesa doing it, or Vestas. So I don't see any of them do it. I see either the communities are going to do it or the national governments are going to do it if they really want wind to develop in their particular area. Scotland's already doing some of those things. In the States, it could be New Jersey, it could be Massachusetts that have enough tax rolls to force that, and maybe they get more jobs and it'll pay itself off over time, or maybe it won't. But don't you see that as just being this? In the United States, that would be a massive amount of infrastructure to be built. Something we haven't probably done since probably World War II. It's going to be that big of an event. If we're talking about the numbers we're talking about, it's going to be big.
Well, and if we want to prevent hurricanes, we're going to need 100,000 turbines in the Gulf of Mexico, remember? So a lot of infrastructure into that if we want to suck all the energy out of hurricanes like those researchers were talking about. But I digress. So Keystone Tower Systems is back sort of in the news cycle talking about spiral welded towers. And, interesting to think of that technology as, being able to essentially maybe transport a roll of steel and then have some sort of device that rolls it out and robotically welds it on site. Alan, it's not clear how this is done, but it's a pretty interesting concept, and I'm not sure if this is how prevalent these are, or if this is gain traction, or where Keystone is as far as these spiral towers.
Well, it looks like they're putting a demonstrator together down in Texas, because I think the company's based in Denver, Colorado. And the thought process is you can take basically a massive roll of steel or some form of steel, and like Dan was saying, just spirally weld it so you create this spiral tower that tapers, but at the same time you're welding it continuously all the way up, so that you bring in raw steel and you pump out a tower out the back into your factory. That eliminates all the transportation of tower segments and then stacking those tower segments out on the ocean, or putting them together and then dumping them into the ocean, so to speak. So that it's a sort of getting rid of all the transportation and all the infrastructure that's needed to move this tower. It can be done on site. And I think the number they tossed out was, if you're making 15 turbines, putting a facility in would pay for itself. So it's some sort of like, put it in, make all the turbines, take it down, go to the next spot sort of event. But most of the sites in the United States are talking about way more than 15 turbines. So then the economics play, right? If you're making 50 or 100, like they will in the United States, then this spiral welded tower thing could be an interesting development. And don't you see, like, and this is about the time where investment groups will start to pick up on the amount of money that's going to be invested on the northeast of the United States in particular, and start putting venture capital into unique, probably very profitable technologies that will going to just be implemented up and down the coastline. So say they built 50 of these different little, not won't be little, but different spiral welding tower factories up and down the coastline. That could be a great business. And I think if we watch to see who invests and how much they're investing in these technologies, is it going to determine winners or losers before we get to the time of building off the offshore wind turbines. But we're going to see a lot more of this. This is cool. I can't even, can you imagine, Dan? I mean, you know how massive these towers are. Can you imagine bending steel like that and welding at the same time? It seems like monumental kind of massive structures to be playing with.
Yeah, well, it says they secured their first commercial order in 2019 from a major turbine OEM, and that here in 2021, this is where that full-scale plan is going to start to come to fruition. And then they're hoping to do on-site in collaboration with the Department of Energy in the U.S. in 2023. So it looks like, they're going in the right direction. And that, I mean, it is a really interesting concept. And they also talk about on their website that in an ideal world, the towers would be wider at the base, and this allows them to be wider at the base than they already are.
Oh, sure.
And that's another interesting, just like, with Cobod, they talk about how they can make a tower taller because they can make the base out of concrete and make it wider.
Right.
So that base width problem is actively trying to be solved by Cobod with their 3D concrete printing, and actively trying to be solved here by Keystone Tower Systems. So, and it seems like everyone's figured this out, that like you said, if it just only takes 15 towers to pay for itself and make it economically viable to put that on-site manufacturing plants, then 15 towers is nothing. That's a third, if that, of a typical U.S. wind site now. Maybe less so than Europe, where, in Europe they'll put a single tower here in this town or a couple here in this town. But in the U.S. it seems to be pretty big projects, closer to 100 than 15. So, so that's interesting. Definitely makes sense, and definitely fits that whole model that everyone's going to just do it all on site and eliminate the transportation problems just in that. And then next up, and this is not wind, but this is just part of this whole renewable energy picture, is so the Mocean Blue. So this is MOCEAN, like M ocean. Mocean Blue X wave energy prototype. The U.S. is funding some projects with this on wave energy tech. They want to put these out in the West Coast to start to go it to get things rolling. The Pac Waves South facility, which is off the coast of Oregon, and the DOE is just trying to figure out how they can advance wave energy technology and eventually get to where they're proven and viable commercially. So the U.S. DOE has put $27 million of funding into research and development for wave energy, and of course this company Mocean is part of that. So their Blue Wave X demonstrator is out there, or Blue X Wave demonstrators out there in the Orkney Islands now. And Alan, based on the photos we've seen this, we haven't seen a good video where they explain like how it works, how it actually produces power, but it's going to have a subsurface energy storage, it looks like, obviously all the cabling and stuff like that. Well, how does this thing produce power?
Well, it's got a central pivot and like two wings, so it's like a bird, so to speak. And if you can picture this in your mind, so it's got this sort of massive piece in the middle and these two arms that float up and down as the waves come through. So one's up, one's down, and these arms move relative to the center pivot point. The way that it seems to work is sort of like a little bit of a ratchet flywheel event, where it just kind of nudges some spinning mass, which is then connected to a turbine, a generator, to generate electricity. So as the waves go up and down against these two arms, and there must be something about the distance in which the arms are set at, and the little look like scoops on either end, to maximize the amount of displacement that they get. So it's like pumping out, like those little hand truck things you saw in silent movies where they're going down the train tracks, and there's one guy on each side, and they're pumping up and down to make this little cart move. It's sort of like that. That's what it looks like. It's a similar technology or similar mechanical approach to it. So it's there's interesting things happening in waves. The question is, how much energy can you generate versus the cost, right? And is it going to be efficient? And I think that's why The U.S. is going to be involved in it to try to figure those things out. And off the coast of California, particularly up in Oregon and Washington, where the continental shelf drops off, and you have to talk about floating devices, maybe wave technology is one of those things you could easily tap into, because there's plenty of waves off the Pacific Ocean, and it's always pretty constant. So in theory, you can then generate power day and night, mostly. How it handles rough seas and the whole thing is yet to be determined. But do you see how this could be sort of advantageous in the sense that waves are always kind of going, and even if they produce a relatively low amount of energy, at least it's some. Added to the grand total of wind and solar and whatever else we're going to come up with, maybe it's another piece.
Yeah, and that's what is interesting is, we've talked about tidal power in a previous episode. There's obviously wind, there's obviously solar. Now there's some wave energy, and there's no details about how much this outputs. So I don't know if it's a megawatt, a kilowatt, who knows? There's no reporting on how much it produces, but that's obviously why the Department of Energy is funding research and development, just to see what we can pump out, I guess, and what it's eventually capable of. But yeah, it feels like this is going to be this interesting, like we've got these huge mechanical creatures in the ocean, like all over on the shore, like just everywhere.
Yeah.
Are we going to have pond power soon? Like, there's just something in just a little floaty, like a little boat just cruising around somehow harvesting something.
Great
like,
question.
I don't know.
Yeah, I don't know. The
stream power.
Well, this wave unit is so massive that they can actually fit inside of it, right? So you can work inside of it. That's interesting because
Airbnb,
so if you're sitting inside the central piece and it's bobbing up and down and left and right, and you're in this enclosed space, that's like your maximum seasickness kind of event. They got to get hazardous duty to be working inside of this unit if it's deployed. It's interesting. You always hate to poo-poo a new piece of technology in the sense that you're not really sure like you were saying, how much energy it can produce. Hopefully somebody has done that because we're talking about like 15 megawatt and 20 megawatt eventually types of wind turbines. You can generate a lot of power off a wind turbine. How much can you possibly generate off of waves? That's yet to be determined. I know Paul Geip had mentioned something to us about wave power's been around for a while and it hasn't really come to anything massive yet. But there's different approaches to it, and maybe this is one that will be beneficial in some parts of the world where there's just constant waves. Alaska, maybe one where, except there's ice up there. What do you do with the ice? So maybe you are talking about Washington State and down the coastline as your places where this could be developed. But eventually it comes down to levelized cost of energy. What is it? And we haven't seen numbers yet, so we'll just have to keep our eye on it.
Well, moving on, Australia is having a go at the moment. They're excited to report that 5,899 megawatts was churned out on Tuesday of, what day was this? I guess Tuesday of this week, so that would have been July 19th as a high output for the country. Now that South Australia has a number of extra wind farms online, and constraints that were previously capped have been relieved. Things are just sort of kicking and outputs quite high there. So I expect this is just going to be a trend with every country, that each day is almost like a new record, right? Yeah,
it will be. And especially as we add more and more wind turbines, these numbers are going to get dwarfed. In 10 years, you're going to look back and say, that's nothing. It's a drop in the bucket. Don't you think that if Australia goes after wind like they probably should, that these numbers are going to be tiny, and we're not even going to think of them as being all that difficult to achieve? So this is interesting, though. I mean, they did make a big press release about it. I saw it in a couple different sources. I saw it on LinkedIn. I think I saw it on Twitter. That's good. People are paying attention. That's good. If anything comes out of this right now is people are paying attention to how much energy wind is creating. I don't think anybody has a sense of what it means yet, but they will. And this is part of the general population switching to electric power over time, like was going to happen in many parts of the world. And it's just going to be a different way of generating power. And we ought to celebrate those successes. And this is something to celebrate. So this is good. This is really good.
Well, and with more news from Australia, that there's a consortium of companies that want to create what would be the world's biggest renewable energy hub in Australia's southwest to convert wind and solar power into green fuels like hydrogen. It's reporting from theguardian.com. And so these energy companies want a 15,000 square kilometer area, 50 gigawatt capacity, cost $100 billion. And they want to, like I said, green hydrogen, and essentially this is going to be very comparable to the current capacity they have for coal, gas, and other renewable plants currently in their energy market. So my question to you, Alan, is why green hydrogen and ammonia? Like, what are those fuels important for?
Well, the ammonia is for fertilizer, at least it is in the United States, and that's a big industry in the States in the farming areas. And then the hydrogen, I think the thought is that they're going to take large trucks and industrial equipment and convert them from diesel to hydrogen. That's a big transition to make. That's not particularly easy to do. But there was, at least when I recollect, the last time I dealt with Australia a lot was when we were developing a solar car back in college, and the solar car race across Australia was a big deal. So you see all these, I think there are 3 trailers long trucks that ramble across Australia. There must be a lot of trucking because a lot of the bigger cities obviously are on the coastline, and that's a huge country. So getting from one side to the other is a big deal, and it must take a lot of energy to do that. Doing it with a cleaner energy would make a lot of sense. And I know Tesla, as we all know, Tesla is trying to develop a battery-powered truck, shipping trucks, to help reduce emissions and the whole thing. I'm not sure hydrogen's the way to go, though. That's it. The green hydrogen thing is still a mystery to me in terms of how real is it versus the cost to generate it. And Rosemary Barnes did a really good job about this in one of her YouTube videos, talking about it takes a lot of energy. It's only like 30% of the energy used out of it. So you put 100% of energy to make it, and you get 30% back out of it. That's not a great return on investment. And so is the battery power a better solution? And I don't know if you watched one of her recent videos, and I think this is part of sort of the electrification and new energy solutions in Australia. But Rosemary was talking about using electric vehicles to then sort of provide stability to the grid, because everybody's, or a significant portion of society in Australia will at some point have an electric vehicle or electric truck or electric tractor trailer. If it's plugged into the grid on times where the grid can't feed all the energy from wind and solar, say at nighttime, maybe there's some feedback from the cars and the trucks back into the grid to stabilize the grid. So it's kind of, let's say, this little bit of an eco structure that will develop. And Australia, I think, is in a really interesting place where it can do that now. I know there's a lot of infrastructure already built, but it's not so much like the United States, where the infrastructure is aging and really hard to, because we've sort of developed along the East Coast so much. There's a lot of Australia that's still open and for development, so to speak. So this is going to be interesting to watch. And the hope is that the United Kingdom, European Union, different parts of the world, Australia, are going to try different types of energy production and to support their electricity and energy needs. And let's see who the winner is. Don't you see that's being a better solution than everybody doing the same thing? The variability helps here.
Yeah, I would agree. And of course, this is, like we know Boeing and Airbus have some, I think they're pretty much backburnered at the moment, but they've been tinkering with hydrogen planes, right? And they're trying to develop out that technology and see what that looks like, because, right, some of these countries want that to happen to eliminate the jet fuel emissions from the atmosphere. But they're a good, 20 years away, 30 years away from that, making that happen? Pretty long way away, if not.
Yeah.
Yeah. And so maybe if you get started now, there could be cheap enough hydrogen fuel, or that's getting going. Whereas I know we've had to play catch up with wind in a lot of places where, hey, if we'd invested in this 5-10 years ago, maybe we'd be closer. We wouldn't have some of these problems. It's always looking back at what we could have done, but this seems like pretty forward thinking potentially, where there might not be as strong of a demand for these fuels now, but maybe in just a couple of years, maybe there really would be.
Very likely. Very, very likely.
Well, and the consortium said that they expect the market for green hydrogen globally to be $50 trillion by 2050.
Dollars?
Yeah, 50 trillion US.
Really?
Now, that's a really round number. Anytime you see really round numbers, like maybe it was like 48 million, but they're like, let's just call it 50. But it's a very round number. So I'm skeptical of it, highly skeptical. But, you make these predictions.
Well, yeah. What's the combined economy GDP of Europe and the United States together? It doesn't approach that, I don't think. That's a big number. That's a really big number.
It's a lot of trillions. It's a lot of trillions. Yeah.
There's a lot of zeros there. Huh.
Maybe.
That's
29 years. 29 years in the future. So we might be conquered by apes by then. Like, we don't know. Like, dinosaurs might be back.
I just think of all the small business pitches that go, the market's 50 trillion, and if I get 1% of that, that would be 500 billion, and we will be rich, right? No, that isn't how it works. But once that number gets out there, there's going to be some conference room where someone's giving a pitch that's going to go exactly like that. Wow.
Yeah. But good things happening in Australia for sure. Really making some moves and seeing their output of renewable energy, continue to rise. So that's it for today's episode of the Uptime Wind Energy Podcast. Thanks for listening. Be sure to subscribe to the show and check out the show notes or description if you're here on YouTube for Uptime Tech News, where you could sign up for our new newsletter just to get a notification of the new podcast, other wind tech articles from around the web, videos, whatever we find that we want to share that we feel like will keep you up to date with what's happening in the industry. So thanks again for watching, for listening, and we will see you here next week on Uptime. Operating a profitable wind farm is all about mitigating costs, minimizing risks, and being efficient with maintenance, repairs, and upgrades. It's incredibly expensive to send a team of rope access technicians up tower to make even simple repairs. We also know how costly lightning damage can be, requiring inspection, repairs, and downtime for even minor lightning strikes. Maximize the time efficiency of your techs and prevent future lightning damage by installing our Strike Tape LPS upgrade the next time your crews are going up on ropes. Learn more in today's show notes or visit us on the web at weatherguardwind.com.